Today we are going to dive into a topic called context engineering, the secret for smarter AI. Why your AI gives vague answers and the exact technique to make it 10 times more useful. You ask AI a question, you get a useless answer. This is your problem statement. Without context engineering, if you ask an AI, why did our pipeline fail, it might give you an answer that is like literally vague. Sometimes there could be many reasons. Check your logs, verify connections, ensure data quality. But when you provide some context, that means the same question, and you're also providing the run logs and schema information and memory, then you might get an answer which is accurate, like below, which is shown here. Fact orders timed out at 4.2 million rows. Add cluster by order date to your Snowflake table. The difference is context engineering, not a better model. So, what exactly is the context engineering? The art of dynamically constructing the perfect information payload that is sent to an LLM beyond just a system prompt. So, as you can see here, you will also send system prompt that contains role, tone, rules, and expertise. You will be sending retrieved context like RAG, logs, docs, DB results, and you include memory like past turns and decision made, and you also include tools and state like available actions and environment. This is different from prompt engineering. Prompt engineering is what you exactly ask an LLM, but context engineering is everything surrounding your question. Building context in Python. So as you can see, here is a snippet of code that I have used to show the demo about this context engineering. So this, as you can see here, you are sending system prompt, retrieve context, memory, and tools. I will show you in detail later. Why it matters? The impact of good context is you will get 10 times more specific answers when you compare to prompt only approach. You get 80% fewer hallucinations with grounding context, and this is number one skill in AI engineering towards AI 2026, and it is required at Google, OpenAI, Anthropic, and Meta for AI engineering roles in 2025 and 26. So where context engineering wins. Here you can see some of the use cases like data engineering when a pipeline failure occurs and you need to diagnose with live log schema and run history injected as context. And you can also use them in AI agents, agentic loops where memory, tool state, and past decision guide the next action. And you can also use enterprise chatbots like customer support with CRM data, past tickets, and user profile as live context. You should also know the dark side of the context engineering before you apply it. So sometimes there is a problem called context window overflow. Too much of context hits token limits. Open source LLMs often fail after 50% of advertised window size. Lost in the middle. LLMs pay less attention to the content in the middle of a long context. Critical info gets ignored. Latency overhead. Fetching, filtering, and assembling context adds 200 to 800 milliseconds per request in real systems. Token cost explosion. Injecting 10k tokens of context every call multiplies API cost rapidly at scale in production. Garbage in and garbage out. Poor quality retrieved context actively makes answers worse. Retrieval quality is everything. Privacy and security risk. Sensitive data injected into prompts or context engineering can leak via logs, caches, or model outputs unintentionally. Here is the comparison between the prompt engineering and context engineering. Focus, as you can see here, prompt engineering is about how you ask the question, context engineering is what surrounds the question. The scope of prompt engineering is static text crafting, context engineering is dynamic payload construction. Answer quality for prompt engineering is generic and hedged, while in context engineering it is specific and actionable. Prompt engineering also the challenge is wording sensitivity, and context engineering the challenge is token cost, privacy, and latency. Prompt engineering, as per the industry trend, it is declining in AI roles, but context engineering is fastly growing skill in 2025 and 26. So here you can see the sample snippet of code without the context engineering. As you can see here, I'm only specifying the model and also the role and then the prompt, the question that is used, that is asked. But with context engineering, you can see here that I'm also providing a strong system prompt, and I'm also providing some run logs and also memory and tools to the LLM. So this is the output when I ran that Python script. So with context engineering and without context engineering. So you can see here without context engineering, the LLM is responding in a vague manner. As you can see here, it is telling, I'm sorry to hear that pipeline failed. However, without more information, it is difficult for me to pinpoint the exact cause and provide a solution. So it is asking back a lot of questions that we need to provide again. But with context engineering, it is, yeah, as you can see here, it is figuring out the root cause of the problem. The pipeline failed because due to the full scan of the table, leading to a query execution time exceeding 300-second limit. And it is also able to tell us why it happened, because the full scan occurred because the table is not optimized for querying large sets. Not only that, it is giving you a fix, like to fix this issue we can optimize the query by clustering the table. So it is also telling you in detail what exactly you can do to fix the issue. So this is all about context engineering. I hope this helped you to understand the difference between context engineering and prompt engineering, and when context engineering is really useful and when and why this context engineering is really helpful now. Thank you.